Cool guys, so looking at the components that make up the rudder for the Bro RC bodyboarder. First of all, we have a very strong 4mm thick stainless steel drive shaft, just so they can endure the impact of the debris in the ocean. The rudder itself, we use what we call a bifin. This bifin, just looking at it, has a number of performance functions. One of the things you can see are the blades of the bifin are actually towed in at the back, so that when the board's traveling forward, the faster we go, we actually get some tail lift, and that's almost like the surfer itself, or himself or herself, moving the CG forward onto the board to get more speed down the face of the wave. So that only really comes into play once we're at speed, but it's to really emulate that moving of the CG forward. The other thing, the reason we use a bifin is when we turn, the fin actually spades in and it creates what we call a yaw. So when it turns, the fin spades in, it digs the tail down, picks up the opposite corner of the board, and it gives us that 3D yaw effect. If we were just running a plain center rudder, you'd have more of a two-dimensional turning effect around your turning circle, where with the bifin you get this sort of a roll and yaw. So you'll see the bodyboarder when it's turning, even though it's quite a wide flattish base surface, you're still able to get its rail up in the turn and emulate that yaw. Right, so and then all of this is assembled with stainless steel nuts, washers and lock washers. And then I'm going to show you what we call a little clutch effect once it's assembled, which really just enables us to overcome some big impacts and not damage the servo, the steering servo itself. Okay, so here we have the rudder assembled. It's definitely not the most what we would call dynamic rudder, but that's not the purpose this rudder is serving. We're not traveling at speeds of 100 kilometers per hour in the water. We're actually traveling at speeds maybe closer to 25 kilometers per hour. But what we are wanting to achieve here is to have a robust rudder that can generate performance factors, which this does, but also that it can endure the impact. I mean, I'm sure a lot of you have seen in the videos, we do some big jumps, huge lands in the ocean. We hit a lot of debris, kelp, etc. We land on the shore break a lot. So you want a rudder that's going to endure the impact more than be as efficient, dynamically efficient as possible. So here at the top where we have our servo arm, you can see I've basically got it sandwiched between two fender washers, stainless steel fender washers, and we nip that up when we install the rudder. And what happens is there's enough pressure on there to steer the rudder without any impact. But if we do perhaps hit the sand hard or hit a piece of debris, this is allowed to slip a little bit between these two washers, and that takes a large degree of the impact off the actual steering servo. And simply what will happen is your steering will definitely be out of alignment, but what it will allow you to do is to correct it enough to be able to point the board towards shore, bring it back, and then just realign it. I've used this for quite some time now, and I can honestly say that it saved my servo many a time, rather than breaking a servo and being stuck out in the ocean with your board going in circles. So the rudder shaft fits through this stainless steel bush, which is molded into the board in the process, totally sealed on the inside. And you can see it's a very thick walled stainless steel bush. It's a very nice fit. So there's very little wear in here, and no grease or anything is required for lubrication in this, and there's no corrosion issues because it's stainless steel on stainless steel. Right, so again, keeping things as simple as we can, just because of the ocean. To make up the servo push rod, a rudder push rod, what I use here is a 1.46 mil 316 stainless steel rod, and it's running in a nylon tube, which is an inside diameter of 1.5. So there's very little space between the stainless steel rod and the tube, which helps with sealing it. What you can do as well, what I do in preparation, is I spray a little bit of grease inside this tube. But this tube is made up in a complete length. It's able to be installed as so. And what's nice about it is a lot of people use little brass linkages here with little Allens on either side, etc. But that works well, and it's quite awesome to have perhaps with a model RC boat. But in the ocean, all those things just corrode and they eventually pack in and break and give up. This is prepared with a what we call a Z bender. I can tell you I've never had one of these Z bends fail on me. Once it's located in the rudder arm or the servo arm, it's there to stay, and it does this job fantastically. There's also a little degree of flex in this push rod as well, once again taking impact out of the servo. So it's fitted through you can see here, a silicone grommet that's fitted through the board. The silicone grommet over here, it fits through there and just simply runs straight to the servo and does its job fantastically well.